Okay, what's going on, folks? Mr. Brunswold here. All right. So two terms that kind of get confused a lot when we're learning about motion are speed and velocity. And it's kind of understandable that people get them confused because they're really similar in the sense that they both refer to how fast something is going, right? So they both mean how fast something's going. So what's the difference? Well, the difference is that speed is a scalar and velocity is a vector. Well, what does that mean? Scalars are just numbers with units, right? So speed is just like a number with a unit. A vector is also a number with a unit, so a vector is also a scalar, but they also include direction. So this might be a little bit confusing. Let's just go through a few examples to talk about the difference between speed and velocity, and I think it'll make sense. The biggest key here is that velocity is a vector and vectors include direction. So, car traveling at 25 meters per second, that's a speed. So go ahead and write that example down. A car traveling at 25 meters per second. Velocity, on the other hand, would be a car traveling forwards at 25 meters per second. Forwards is a direction, so this is a velocity because we know A, how fast the car is going, but B, what direction it's going as well. It's moving forwards. A truck moving at 4 miles per hour, okay, that's a speed. Velocity would be a truck backing up at 4 miles per hour, right? Now we can tell that it's moving backwards because it's backing up. So again, the difference here is that the speed doesn't include a direction and the velocity does. An airplane flying at 800 kilometers per hour, an airplane flying north at 800 kilometers per hour. So again, north is the direction, right? That's the difference between um, speed and velocity, is that speed doesn't have a direction, velocity does. A caterpillar crawls at 6 centimeters per minute. A caterpillar crawls down a tree at 60 centimeters per minute. Right, so that's the difference between a speed and a velocity. So up next, you're going to come up with your own examples, come up with 4 different examples of speeds and velocities, um, just to show me that you understand the difference, okay? All right, so scientists would prefer to know the velocity of an object over the speed because it gives more information about the motion of the object. However, because we are studying objects that are moving in one dimension, so like in a straight line, we won't be listing the direction with the velocity of our objects. So what do I mean by one dimension? I mean like we're just going to be looking to begin with at objects that are moving just forward and back, or just up and down, or just left and right, right? But not, these objects won't be moving in more than one direction at once, so they won't be moving up and down and left and right, and they won't be moving, um, left and right and forward and back at the same time. It'll just be one or the other. And so for that reason, we usually don't actually indicate the direction. Scientists are kind of lazy like that. They've got a shorthand. So instead, objects that are moving forward will have a positive velocity, and objects that are moving backwards will have a negative velocity. So for example, a toy car moving at 0.5 meters per second is moving forwards, and a person moving at negative 1.5 meters per second is moving backwards. So hopefully that makes sense. If you have any questions about this, let me know. Yeah, otherwise, there's going to be a short quiz on velocity, position, and time tomorrow.